Hey, welcome back to Math with Patrick. Today is November 1st, and we're solving problem 305 from the Daily Epsilon calendar. The answer today should be 1 because that's today's date, and last but not least, we do have assistance from Professor Quill, who will be helping us with this trig problem today. All right, so looks like we're just adding up a whole bunch of different cosine values. We have cosine of 36 plus cosine of 108 plus this plus that. And so let's see where these angles are going to fall on our unit circle, just so we have some kind of visualization of what's going on. So 36 degrees is going to be roughly a third of the way to 90 degrees. And then 108 is going to be a little bit past 90 degrees. 252 degrees is going to be almost at the 270 degree mark. So I'll do something like this. And then that 324 degrees is kind of getting close to all the way around, kind of getting close to 360, but not quite. And I do think actually that this is a symmetrical diagram. Like this right here is 36 degrees. But then once we take like 360 and subtract off 36 degrees going in this direction, that is going to be the same thing as going all the way around the circle, 324 degrees. So right here, I can think of this angle as another 36 degrees. And then for the 108 and the 252, these are also both symmetrical. 90 plus 18 is going to give us 108. And then 252 plus 18 will give us that 270. Just for symmetry's sake, I'm also going to think of it as starting at 270, subtracting 18 degrees, and getting 252. And the cosine function essentially tracks how far to the right or to the left you go from this midline to line up with our endpoint right here. And so, well, this should have been symmetrical here. But cosine of 36 and cosine of 324 are both going to be this distance right here. Again, this is the unit circle, and so our radius, or this total distance here, is the number 1. And then the values for cosine of 108 and cosine of 252 are going to be less, both in terms of the fact that they're negative because we're going left, but also less in terms of absolute value. So these numbers that are negative aren't going to outweigh our positive values over here. And now we just got to figure out what cosine of these values is. Fortunately, though, I found these in a previous video. So 36 degrees, this is the same thing as pi over 5 radians. My explanation here is that we would need 10 chunks of 36 degrees to go all the way around the circle. And all the way around the circle in radians is 2 pi. It kind of comes from the fact that the circumference of our unit circle is 2 pi. And so if I have 10 chunks of 36 degrees, I just divide all that 2 pi by 10. And so pi over 5 is our corresponding radian degree measurement. And I'd rather just work in radians because that's what I'm used to. And that's what I did in previous videos. So I know the value of this. Coming up in a sec though. 18 degrees is just half of 36. And so I could think of this 18 degrees as like a pi over 10. Although I'm not doing cosine of pi over 10 because pi over 10 would be an angle, say here-ish, like half of that 36. And cosine of pi over 10 would actually be quite long, almost nearly the number 1. So instead of actually thinking of this as cosine of pi over 10, because that wouldn't work, I actually want to think of this distance as sine of pi over 10. The idea here is that the sine function tracks how high you go from this angle, and this height distance right here is actually going to be the same distance as our horizontal distance back there. So to kind of get my equation going and adding up all these things, I will add up both of these as cosine of pi over 5, and then I'll do a times 2 at the front just because I have 2 of them. And then I'll subtract twice sine of pi over 10. Subtracting because this value is going to be negative, twice because we do have 2 of these angles that are kind of going backwards. And then this sine of pi over 10, again, technically represents this vertical distance here, but just kind of because of symmetry with right triangles, that's also going to be that orange distance that I drew earlier. Now we can just substitute in values for cosine of pi over 5 and sine of pi over 10. And actually, maybe first I'll just factor out this 2 so that I don't have to think about multiplying this 2 to both of them. And if you want to know where these values are coming from, I do recommend watching the January 20th video first, because I use the information in that video in the one on March 11th. And you do need to see both of these if you really want to know where I'm getting both of these values from. So cosine of pi over 5 is the same thing as 1 plus root 5 over 4. And then sine of pi over 10 is the same thing as negative 1 plus root 5 over 4. And here, let's do the subtraction on the inside first. Since we have a common denominator, we can just kind of smush everything in the same numerator. 1 plus root 5 minus, and then negative 1 plus root 5. It is important that this minus applies to both of these numbers. We still have a 2 on the outside. Maybe I'll smush the 2 and the 4 together. Essentially, that's just going to produce a 2 on the bottom. And then in our numerator, we can see that this positive root 5 is being subtracted by another positive root 5. And so those root 5s go away. Then our positive 1 is being subtracted by a negative 1. So it's kind of like adding 1, and we only get a 2 in the numerator now. And 2 over 2 is equal to 1. So the hard part of this problem is knowing that these trig values are true. But again, if you want to see why it works, I have some explanations in the description below. So that's my answer for today's problem. Thank you for coming along, and I'll see you tomorrow. Bye.